Hello, everybody. Welcome to today's lecture. Today we're going to get started on percents. So this is chapter 6 in the textbook. We've already talked about fractions and decimals, so this is going to build off of those chapters quite a bit. So make sure you're familiar with decimals especially, because what we're going to see here is that percents really are just decimals, just represented in a different way. Okay. So percents, they're probably something you've seen before, right? Because we tend to use percents a lot in our everyday lives, like when we talk about interest rates or how likely it is something, or how likely it is that it's going to rain tomorrow, right? It might be like a 50% chance. Taxes, right? Like a sales tax, which I believe is 6% in Kentucky. Or income taxes and all that kind of stuff, and we will talk about taxes later more in depth. But first, let's define what a percent is. Okay. So first of all, the notation here is this, right? This is a percent symbol. Percent symbol. Okay. If you see that typed, it's usually if you press Shift 5. That's how you get it. Let me increase the size here. 72. So it looks something like this, right? So it kind of looks like a 0 divided by 0 kind of symbol. So let's start with the definition of a percent. A percent is a ratio whose denominator is 100. Okay. So remember, ratio means fraction. Okay. When we talk about a ratio, all we mean is that it's a fraction. Like if there's a 1-to-2 ratio, which we might write as 1-to-2 ratio, 1-to-2 ratio is 1/2. Okay, so it's just a different way of writing a fraction, essentially. So this is in particular a fraction whose denominator is 100. So a percent tells us how much of something we have out of 100, essentially. So if we have 89% of something, then that means we have 89 100ths of it. Or if we have 50% of something, that means we have 50 100ths of it. If we were talking about a 50% chance that it's going to rain tomorrow, then that means that there are, if we were going to do like a simulation, for example, and we did 100 simulations, in 50 of them, it looks like it's going to rain. Okay. So let me write some of that down, I guess. So let's say that means if we have let's say if we have to pay a 6% sales tax, then we have to pay that means that if our denominator is 100, if we think about the percent as in terms of money, this is saying that we have to pay 6 cents for every dollar, or 6 cents for every 100 cents. Or you could even think of it as $6 for every $100. Either way, the ratio is all the same, and it's for every dollar you're paying an extra 6 cents. So we have to pay 6 cents for every 100 cents, which is $1. Or you could think of it as $6 for every $100. The ratio would still work out exactly the same. Okay. But it's easier to think about it like this. So that means if our subtotal is $10, if there's a 6% sales tax, that means that we have to pay 6 cents for every dollar. Well, there's $10, so we have to pay 6 times 10, right? Or 60. So we pay an extra 60 cents. So the total would be $10.60. Okay. Oftentimes, your subtotal is not 10, it's like $9.99 or something, right? $9.99. So your subtotal comes out to be like $10.59 or something like that. Or if we have, for a simpler example of what we're talking about, say if we have 20%, I don't know, let's say like battery left on our phone. This means for every 100 of however your battery calculates its power, like maybe it's by voltage or amperage, I don't really know. But some unit for electricity, for every 100 of them, we have 20 left. So that doesn't necessarily mean we have exactly 20 because the total might not be 100. But if your phone holds, say, like 300 power, then that means we have 20 left for every 100 power that it has. If it was 300, that means that we would have 60 left, right? Because we would do that 3 times to go from 100 to 300. We have 20% battery left on our phone. We have 20 units of power left for every 100, whatever the units of power are. Or for an even simpler example, if we have 10% of the pizza left, it means we have 10 parts left for every 100 left. Okay. Now that's a little confusing. That is technically what it means, but you're not typically cutting a pizza into 100 parts. So what do we really mean by this? Well, a good way to think about this is by using ratios. Okay. So these should be in the same ratio, meaning that our 10 out of 100 parts, when we divide those numbers, we should get the same number. Whatever this quantity is, we should get the same number for the actual ratio of however much pizza we have. So, say we cut the pizza into 8 pieces. Whatever number we divide 8 by should be the same thing as 10 out of 100. Now, how many slices of pizza do we have left? We don't know. So let's call that X. And now we could use this equation to solve for x. This is just like our equations before. We just got to get 8 on both sides. We just have to get x by itself, so we should multiply by 8 on both sides, right? So this is 80 out of 100 equals x, and you can cancel one of the zeros here, so you have 8/10. Okay. So x is 8/10, so that means we have 8/10 of a slice of pizza left if we have 10% of it. So we have most of the slice left. Okay. So this is a helpful way of thinking about it to convert it into a way that makes more sense in the context of the problem. So typically to find a percentage, let's talk about, well, let's talk first about converting percents to fractions and decimals. Okay. This might be helpful because we've already talked about fractions and decimals. So if we put it into this context, it might make more sense for the time being. Forgot the word percents here. So this isn't hard to do because, like we just said, percents are just fractions whose denominator is 100. So we could just take whatever the number it says in the percent is and just put it over 100, kind of like I already did here, right? I said it was 10 over 100. That's exactly how we would do it. So let's just use some more examples like that. If we have 25%, well, to convert this to a fraction, all we have to do is take this number and put it over 100, because that's what a percent is by definition. Okay. Now at this point, you could go ahead and simplify the fraction if you want. Here you can take a 25 out of the top and bottom and get 1/4. And then you could also convert the fraction to a decimal. But we don't even actually need to do that. Okay. So first, let's just note for fractions, put the number, or just put the percent number over 100. Okay. And then reduce if necessary, meaning if the problem says to do that, if you can do that, if you want to do that. Okay. So let's look at a couple more examples of going to fractions, and then we'll look at going to decimals. Okay, so like 33%, for example. We're going to do 33 over 100. And then this one we can't even reduce, so we would just leave it exactly like that. Okay. Okay. So let's look at one more here, because we couldn't really even do anything more with that one. What about just 50%? Okay. So 50%, you might know this as about half, right? Or it is exactly half. So where do we get that? Well, this is 50 over 100. And now if we want to reduce this, the 50 over 100, you can cancel out the zeros here. And then you get 50 over 10. And then you can cancel a 5 out of the top and bottom if you want. And you can get 1 over 2. Okay. So now let's look at going to decimals. Okay, so percent to decimal. This one's actually even easier. Not that this one is too bad, right? We just have to divide by 100. But for the decimals, we don't even really need to do any work. All we have to do is move the decimal place over to the left twice. Okay. So move decimal place to the left twice. Okay. So 33%, for example. Well, if we don't write down the decimal, we assume it's at the end of the number, so it's right here. So we just move it to the left twice. So this is going to be 0.33. Okay. 50%. We're going to take this and move it to the left twice. So we're going to get 0.5, which we also know as is 1/2. We found that out in the decimal section. So why does this work? Well, it's because we're dividing by 100. And remember, if you go back to in chapter 5, we talked about how multiplying by 10 moves the decimal to the right one time. Dividing by 10 moves the decimal to the left one time. When you're dividing by 100, 100 is 10 times 10. So it's really like you're dividing by 10 twice. In other words, you're going to end up you're going to move the decimal to the left twice. So it just comes from that rule. Okay. So there's really not a lot to do here. If we have something like 34.83%, okay, then we just take the decimal and move it to the left twice, and we get 0.3483. Okay. If we have 6%, like the sales tax, and we take that decimal and move it to the left twice. Now, there's no number right here, so we just assume that there's a 0 because we can put as many zeros to the left of the number as we want. So this is going to be 0.06. Okay. Now it stands to reason if you wanted to go the other way, you would just do the opposite thing. You would move the decimal to the right twice, and that is exactly what we would do. Okay. So decimal to a percent, we just move the decimal to the right twice. Okay. And it's exactly because if you're going from a percent to a decimal, you divide by 100. If you're going the other way, you multiply by 100. Okay. We're going to see that with the fractions. So let's do this first, and then we'll look at the fractions. So if we have 0.0075 as a decimal, and we want to turn it into a percent, then we should take that decimal and move it to the right twice. So this is 0.75%. Okay. If we have 6.82 as a decimal, then we want to move this to the right twice, and we get 682%. Okay. So I picked this one on purpose to show that we can have decimals that are over 100%. I mean, percents that are over 100%. 100% is not necessarily the max. This would just be, if we have 682% of something, then that means we have 682 for every 100 parts. Okay. So we would typically see this maybe in like a financial context, like if you invest your money and you gain a lot of it really quickly, or like if a business's profits go up a lot, quarter to quarter, you might see them say that they had like a 183% increase in profits or something like that, right? So we can have decimals that are more than 100%, just like we can have improper fractions, right? We can have 4/3 of something, or 10/5 of something. If we have 0.758 and we turn that into a percent, we move the decimal to the right twice and we get 75.8%. Okay. So 75.8 for every 100 parts. All right, let's look at fractions to percents. Okay. And as always, if I'm moving too quickly here, I encourage you to just pause the video, do a couple more practice problems, maybe back up and rewatch that part of it again, etc. That's the nice thing about these videos, is that you're completely in control of how you watch it. Okay. So let's look at fractions to percents. Well, what did we do when we did percents to fractions? We divided by 100, right? We just took this number and we divided by 100. So to go the other way, it stands to reason we should do the opposite. So the opposite of dividing by 100 would be multiplying by 100. And that's exactly what we're going to do. To go from a fraction to a percent, say with 1/4, we should multiply by 100. It's usually written as multiply by 100%. Okay. So we take 1/4 and we multiply by 100. You can use the parentheses notation or the dot notation or whatever you want. So just remember how we multiply fractions. We do 100 times the top, and then divide on the bottom. Okay. It's like we're doing 100 divided by 1 times 1/4. So 100 times 1 and 4 times 1. 100 divided by 4 is 25. So we end up with 25%. Okay. Technically, maybe we should have percent signs on this, just to make it clear that that's where we're going to end up. Okay. Okay, let's see. How about we can do 1/2, right? Because we already know that should end up at 50%. So we multiply by 100 and we get 100/2. Again, maybe put some percent signs on here. I'm not going to be picky about this, but if you're looking in the book or online anywhere, this is how they'll write it. Okay. And 100 divided by 2 is 50, so we get 50%. Okay. So this is what I meant by it really builds off of the fraction and decimal section. There's not a lot of new techniques here. It's just using the previous techniques in new ways, okay, in a different context. What about 1/3? Okay, 1/3 times 100%. Well, this is going to be 100 divided by 3. And if you do this, well, you could throw it in a calculator if you want at this point. Okay. When we do that, we're going to get 33.3 repeating percent. Okay. And that's exactly what we would do. So you always want to represent your end number as a decimal. Okay. We don't want to leave a percent as a fraction, like how I have the 100 divided by 3. A lot of times we do like to leave things as fractions, but it's not really the convention when we use percents. It's always converting it to a decimal. You're never going to see something like this as the final answer. It'll always be in decimal form. Okay. 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 Let's take a look now at 6.2. Okay. And by the way, if you're confused about why we skipped the rest of chapter 5, I kind of just decided that chapter 6 should be the priority because it's a very important chapter. But I think we'll have plenty of time to finish chapter 6 and then go back and do the rest of chapter 5. Okay. The last three sections of chapter 5 are kind of independent of everything else. So we didn't really need them for chapter 6. But I think it's actually kind of helpful to know chapter 6 before even diving into those sections. So we're going to do those next. So 6.2 is about applications of percents. Okay. Which we already saw a little bit of because I just talked about the sales tax, right? So let's talk about what does X percent of Y mean? Okay. And how do we solve that? So what I mean is when we say, okay, what does 50% of 10 mean? Okay. In math, the word of typically implies multiplication. Okay. So that's exactly what we'll do here. We'll just take the percent and multiply it by the number. With one important caveat here, which is that if we take the percent and multiply it by a number, the output would be another percent. But we don't want to end up with a percent. For example, if we're doing 50% of 10, we want to end up at 5, right? Because we know that's what half of 10 is. We don't want to end up at a percent at the end. So what that means is first we need to take the percent and convert it to a decimal, then do the multiplication. Okay. So the method here is step 1, convert percent to decimal. Step 2, multiply. Okay. So 50% of 10. So we're going to take 50% and we're going to move the decimal over twice. So we're going to get 0.5. And then we're going to multiply by 10. Okay. So I mentioned earlier about, using this parentheses notation versus using the dot notation. At this point in the class, it's probably good to start transitioning towards the parentheses notation because that's what's always used in math. Meaning like it's the most commonly used thing in math. And the reason is if I write this and if I'm writing quickly, it can be hard to tell like, okay, what is this decimal versus this dot? They look the same. Are they level? Are they both decimals? Are they like what's going on here? So just to avoid confusion, it's a good idea to use parentheses. Or if you're typing, you can always feel free to use the asterisk. Okay. Or handwriting, but it's usually not. Usually we don't write the asterisk by hand. Anyway, so we would go ahead and do this. You would do your the methods that we had for decimal multiplication. Or, when we're multiplying by 10, you just move the decimal to the right anyway, just one time. So we end up getting 5. Now we can combine it all into one step. Okay. Because really what we're doing here, when we convert 50% to a decimal, what we're doing is we're dividing by 100, right? We talked about that. Moving the decimal to the left 2 times, that's the equivalent to dividing by 100. And, even on that note, dividing by 100 is the same thing as multiplying by 1 over 100, right? Because this would just end up being 50 over 100. Technically, again, we're dividing by 100% so that our units cancel out. And then at the end, we're multiplying by 10. So here's a good example of where probably should use the decimal or the parentheses notation. Okay. So this is like everything we just did here all rolled into one step. First, we divide by 100, then we multiply by 10. Remember, dividing by 100, it's the same thing as multiplying by the reciprocal. That's what we use when we divide by fraction, or when we divided fractions. Now, when you're multiplying things, it doesn't matter what the order you do them in is. So we can flip this order around and everything would still work out. Okay. So that means that this would be the same thing as 10 times 1 over 100 times 50. Meaning I can swap the place of the 50 and the 10. Which means that 50% of 10, which is this, is the same thing as 10% of 50. Okay. So this is something people don't often really think about, but when you write it out like this, it should hopefully make sense. And it's a nice little trick that you can just swap the numbers around, because it's typically a lot easier to think about what's 50% of 10 because we know that's half versus what's 10% of 50. So just as an example, if we wanted to do 14% of 50, well, this isn't very easy to do, in our head or otherwise. We're going to end up doing 0.14 times 50. But this is the same thing as 50% of 14. And since we know 50% is half, then this becomes a much easier problem because we can figure out a lot easier that half of 14 is 7. Okay. So this is just kind of a way that you can do it mentally. Just a little trick. It's never going to be necessary. You can always just take the 0.14. So you convert 14 to 0.14, multiply by 50. You can do that in your calculator, and you'll get 7. Okay. Or you can do it by hand. So at this point, it's okay if you just start using the calculator for these calculations, because we already did like a test on the calculations and all that, or homework. So, go ahead and use the calculator, your phone calculator or whatever. All right. So let's just do one more example. If we do 22% of 30, okay, flipping it around is not really going to make it any easier, right? 30% of 22, not really easy to do in your head either way. So this is going to be 22 divided by 100 times 30. Okay. So this part is converting it to a decimal. This part is the of part. So again, you can just move the decimal over 2 times, or you can divide by 100. Doesn't really matter. Either way, you'll end up doing 0.22 times 30. So we get 6.6. Okay. Okay. Let's talk now. I think that we'll finish this video talking about percent increase. And percent decrease. Okay. And then next time we'll talk about the rest of this chapter, which is the remaining applications, like more in depth about sales tax. I'll go through how income tax works in the US. and some other applications like simple interest, okay, like interest rates. So we often hear about, like when I was talking about companies' profits going up, right? And I mentioned we might hear them that they went up by 183%. So what exactly does that mean, going up by 183%? Okay. So to find the percent increase, meaning by what percentage does this thing increase? Okay. First, we find the amount of increase. Then we find what percent the amount of increase is of the original amount. Okay. So it's a little confusing. So let's break it down. First, we need to know how much did something increase. Okay, so if it went from 100 to 150, it increased by 50. Okay. Then we find, okay, what percent is that amount of increase of the original amount? So 100 to 150 increased by 50. So then we take that 50 and say how much of that is a percent of 100, which in that case would be 50%. Right. So let's write down an example here. Say we raise prices from $26 to $36 per unit. Okay. So what's the percent increase here? Well, first, the amount of increase in general, this is going to be the difference of the new price and the old price, right? So you do 36 minus 26 in this case, and you get 10. So the amount of increase is 10. Then next we say, okay, what percent of 26 is 10? Okay. This is kind of a little tricky to answer. Let's try to do this in equation form, okay? Let's say X percent, and then we would divide by 100% and multiply by 26, okay? Whatever number this is, we should divide by 100 to convert it to a decimal, then multiply by 26, and that should equal at the end 10, right? So we have a nice equation for this. So we can forget about the percents because they're canceling out here. If we instead do the 26 divided by 100, because we can do that because we would just multiply the 26 on the top, so the order doesn't actually matter here. Then this is going to be 0.26 times x equals 10. And then we can just divide both sides by 0.26. Okay. So we do 10 divided by 0.26, and we get 38.46. I'm just rounding because it's a long decimal. So it's about 38.46%. about a 38.46% increase. So the decrease would be pretty much the same idea, right? For a decrease, you would do the same thing, except you would find the amount of the decrease. Okay, so like if we went from 36 to 26, it would again just be a 38.46% decrease. So let's just do a different example. Let's say we go from making $10 per hour to $875 per hour. Okay. And what is the percent decrease? Well, first of all, the amount of decrease that's going to be the new amount minus, or I'm sorry, the other way around, the old amount minus the new amount this time, right? Because it went down. So this is going to be, it went down by $1.25, $1.25. Okay. And then two, we say, okay, X percent times, well, we would divide by 100, right? X percent divided by 100% so that we make it a decimal times the original amount, which is 10 in this case, is equal to 875. Okay. Sorry, I did this. This shouldn't be 875, right? This should be the amount of decrease, which is 1.25. So analogous to the situation up here. Okay. So we're doing what percent of 10 is 125, the decrease. So percents cancel here. 10 divided by 100 is 0.1, 0.10 if you like, for 125. And then we divide by 0.1 on both sides to get rid of it. And so we get X is equal to, if you do that in your calculator, we'll get 12.5. Okay. So you can write it out like this if you're more comfortable with that. What percent of, it would be in this case, what percent of 10 is 125? And then you can translate it into math. Either way, we get it is a 12.5% decrease. Okay. So this could be helpful because then you can just think, okay, well, my old paycheck was this much, and instead of having to figure out your new paycheck, you can just take 12.5% off of it. Okay. Okay, I think we'll stop there for today. So some other, like I said, we'll have next time to talk about sales tax, income tax, simple interest, and we'll also talk about kind of doing these problems in a different way. So, okay, if I have $100 and it increased by 50%, how much money do I have? Right? That kind of thing. So going in the other direction with this. So thank you for watching today, and I will see you then.